Okay, so this is a video on solving equations with exponentials. And the first thing that we need to do when solving these is make sure that these both can be expressed with the same base. And what that means is that both of these like big numbers right here both have to be the same number. So this will have to be 2 and this will have to be 2, or this will have to be 4 and this will have to be 4. Typically, it's easier to go from large to small because I can express the 4 as like 2 squared instead of expressing the 2 as the square root of 4. That's a little goofy and doesn't it just doesn't look good. So we're going to go from big to small most of the time. And whenever we have numbers that don't allow this to happen, let's say I have 3 to the x equals 4. We're not going to be able to do this trick. That's whenever you get into like logarithms and stuff, and so we're not going to worry about that right now. So what we're going to do is we're going to write the 4 with a base of 2, and what that looks like is I'll say 2 to the x. That'll stay the same, and then the 4 will become 2 squared. Okay, and now that both of those have the same base, we don't even have to worry about them anymore, and we can just say x equals 2. And that's our answer for this one. It's pretty simple. And just to make sure that that works, we're going to plug this back in to this x here to make sure it works. So 2 squared equals 4. 2 squared is 4, and that equals 4. So we did it right. Okay, so now there's going to be ones with more complex solutions. So let's say I have 2 to the x times, we'll say 4 to the x plus 1. And we're going to say that equals 16 to the x plus 6. So I chose all of these numbers because they're all going to be able to be kind of like watered down into being some form of 2 to the something. So what we're going to do is we're going to leave 2 to the x the same, and we're going to change 4 to be 2 squared raised to the x plus 1, and then 16, that'll be 2 to the 4th, I believe, yeah, raised to the x plus 6. Okay, so now what we need to do is we need to distribute this 2 across and this 4 across so that we're going to use our exponential properties, where if you raise a power to another power, it's going to be multiplication. So we're going to kind of distribute that. So we'll have 2 to the x times 2 to the 2x plus 2 equals 2 to the 4x plus 24. And we're almost to our situation from before. So what we need to do now is use another property where if they have the same base and these two are being multiplied together, we can add the exponents together and write them under one base. So that'll be 2 to the x plus 2x plus 2. And then my right side will stay the same. 2 to the 4x plus 24. And I'm going to simplify this top real quick. So we'll have 2 to the 3x plus 2 equals 2 to the 4x plus 24. And now both of my 2's can cancel. They're not really canceling, but we're going to say they cancel. And we'll say, and now we're just worried about the exponent part. So we'll say 3x plus 2 equals 4x plus 24. And now we're just going to solve this like a regular equation. So I'm going to subtract 2 from both sides, subtract 4x from both sides. We'll get negative x equals 22, and x equals negative 22. That is a big number to plug into this, so let's go to Desmos and see if that actually works. Okay, so our original was 2 to the, so it needs to be 2 to the negative 22. And that's going to be times 4 to the negative 21. And that should be equal to 16 to the negative 18 or something. And it turns out we got the same answer. Nice. So that's how you do equations with exponents. So now what I'm going to do is I'm going to go over really quickly what about horizontal and vertical asymptotes. I'll fix them to make all this white and then black again. Okay, so a vertical asymptote is an imaginary line that a function can't cross that's going vertically. So what that's going to look like is if I have a graph like this, and I have a function that looks like this, I've got a vertical asymptote right here. And we'll say that that's at x equals 1 or something. So basically, this graph is never going to go to the left of x equals 1. And you can have multiple vertical asymptotes, and they'll describe like different parts of equations. We're not going to get into that because you'll probably see that down the line. But we also have horizontal asymptotes, and they're almost the same as vertical asymptotes. They're a little different. So a horizontal asymptote is going to be a line that can be crossed, but it just describes the ending behavior of the function. So if I have a function that does something like this, and I can draw my horizontal asymptote like that. Oh, let me do it as dashed lines. So as you can see, for this one, the function actually will cross this horizontal asymptote at multiple points. But what is important is that this ending behavior ends up flattening out and not really passing this line again. So it more describes what happens at like in the infinities instead of like local situations, because we don't really care if this happens. For the most part, most of the time we really only care like what happens at the very start of something or the very end. So like your negative infinities or your infinities. So how that relates to exponential functions is most of the time they'll end up looking something like this. And its horizontal asymptote pretty much always be 0 unless the graph has been shifted down. So if I say f of x equals e to the x, which is a very common exponential function, you'll see it a ton. If I say that that's what this function represents, and e to this number is just a constant, it's kind of like pi. My horizontal asymptote is 0, but if I said f of x equals e to the x minus 3, that's going to shift this whole function down. So that will look more like this. Where this horizontal asymptote is happening at y equals -3. And for e to the x and 2 to the x and stuff like that, your function pretty much it's not going to cross that horizontal asymptote. It's going to get insanely close to it, but it'll never cross it. It's not like these up here where it'll cross it a bunch of times. This one is not going to cross the horizontal asymptote. So while functions can cross the horizontal asymptote, the exponential functions like this are not going to do that. They're not going to alternate back and forth between negative and positive values like that. All right, that should be everything. So good luck.